Hello and welcome. This is going to be our homework help video for the Unit 5 linear review. For the test coming up, we'll just jump right into it with problem number 1 here. Find the slope of each line. Leave your answer as a simplified proper of improper fraction. That's supposed to say or improper fraction. Catch a typo right off the bat. It's a good way to start. All right. We're just trying to find the slope. Now, the problem here does you a big favor of already bolding 2 points. If you don't have 2 points already bolded, you could pick any 2 points that are on this line where it looks like it goes exactly through 2 of those grid lines. But since we got these 2 points, let's just use those since we know for sure it's exactly going through those points there. Let's connect them up with a slope triangle. All right, and that's a right triangle where we walk along the grid lines to connect the 2 points. Now, what are the dimensions of this triangle? Well, I always walk from the left point to the right point. So if I do that, and if I ever go right and up, those are both positive directions. Left and down are the negative directions, but you should never travel left because we're always going from left to right. So let's say this is 3 across the bottom, it's 3 long, and then this side over here is 1, 2, 3, 4, 5 long. We could label this 3 the run, and this 5 the rise, and then use the formula rise over run to find our slope of 5 over 3. Put a box around that. That's an improper fraction, which the directions told us was fine. All right, let's look for maybe one that's a little different. Oh, they're all about the same. We'll do this one that's negative. Again, they've given us 2 bold points. I connect those up with a slope triangle where I make a right angle to connect the 2 points. I go from the left point to the right point. This time, I start by going down, 1, 2, 3. So that makes our rise a -3. And then our run is 1, 2, 3, 4, 5. And so rise over run becomes -3 over 5. All right, and I think we have answered those. Write the slope-intercept form of the equation of each line given the slope and y-intercept. Well, slope-intercept form, let's just remind ourselves what that means right there. That is the form y equals mx plus b. When we're given a slope and y-intercept, what we're given is an m value and a b value to just plug right into this equation. And then we'll have to do maybe a little bit of simplification. So if I start with y equals mx plus b, and I put a 5 in for b and a 0 in for m, then I would get the equation y equals 0x plus 5. 0 times anything is just 0, so it actually cancels out, and we're left with the equation just y equals 5 for number 5 there. Let's look at number 6. My m value is -1, my b value is +1. If I fill it into y equals mx plus b, I would get y equals -1x plus 1, or just y equals -x plus 1. All right. I'll just do one more real quick. Number 8, my slope is 3, my y-intercept is 4, so this gets me y equals 3x plus 4. Hopefully we're getting the pattern now. All right, now 9 through 12, these are a little bit different. Write the slope-intercept form of the equation of the line through the given point with the given slope. So instead of a y-intercept like up here, we're just given some different point. So we're going to use that point to calculate for the y-intercept. Ordered pairs like this are always an x and then a y, so let's just label this as x and y. And then slope is still m. What you might notice here is we have all 3 of the 4 parts of slope-intercept, so we can just solve for that last part. Again, we start with y equals mx plus b, but we fill in what we have. So the 4 equals -1 times -3 plus b. Notice now b is the only variable not solved. 4 equals 3 plus b, -3 minus 3, 1 equals b. Now to write our final equation, we actually give back these two values for x and y because we were really just borrowing them all along. But we keep using this value for the slope. That will never change. And now we've got a value for the y-intercept. So the slope-intercept equation here is going to be y equals -1x plus 1, or just y equals -x plus 1. That's the same as number 6 there, just by coincidence. All right, a line that's with an undefined slope. Here's where this little acronym HOI-VUX can come in kind of handy. So an undefined slope, that's making me look at the VUX part of this, is a vertical line with an x equals equation. I just need an x equals equation. And what am I going to set it equal to? Well, I'm going to pick the x value for my point. So just x equals 0. That is the equation. And we're done. So is it slope-intercept form? Technically not, but that's because undefined slopes don't have an intercept or a slope. So this is just the equation of that line. There's not many ways else to write it. All right, let's just do one more of these. We'll do the one with the fraction. I fill in my values. -2 equals 1/2 times 2 plus b. -2 equals 1 plus b. Take 1 away from both sides. -3 equals b. Giving us the final equation, y equals 1/2 x minus 3. All right, 13 and 14. Slope-intercept form of an equation of a line through the given points. So we don't have the slope and we don't have the y-intercept. We'll have to calculate for both of them. I'll just do number 14. What I first want to do is I want to make a very short xy table, which is going to help me find that slope. So I fill in my points, 5 across from a -3, just like it is right there. The -1 across from a 5, just like it is right there. And then these arrows on the outside telling me how much it's changing by. To go from -3 to -1, I went up 2. From go to 5 to 5, I go up 0. 0 divided by 2 gives me a slope of 0. Okay, so what lines based on HOI-VUX have 0 slope? Well, it's horizontal lines with a y equals equation. So this one's just going to be y equals 5. Final answer. That one was a little easy, so I'll do 13 real quick. Let's find this slope a different way. Let's use the slope formula. So I label my points, x1, y1, x2, y2. Fill them into the formula, y2 minus y1 over x2 minus x1. And I get 4 minus 5 over -2 minus 0 equals -1 over -2 equals a 1/2. That's just the slope. We're not done yet. We got to find the y-intercept. In order to do that, we start with our equation y equals mx plus b, and we borrow a point. I'm going to borrow the 0, 5 to plug, and then I'm going to put in the 1/2 for m. So 5 equals 1/2 times 0 plus b. Well, 0 times anything is just 0, so that goes away, and we've just calculated here that 5 equals b. So now that I've got a slope and a y-intercept, I write my final equation. Y equals 1/2 x plus 5. Final equation for number 13 there. All right, writing from a graph. Well, you can just make a slope triangle to get the slope. This one goes over 2, up 3. So rise over 1 is 3 over 2. That gives me my m. And then to get b, you just got to look where we cross the y-axis. This one looks like it crosses right there at 1. So b equals 1. You got the two pieces you need. Y equals 3/2 x plus 1. All right, moving on. Write the slope-intercept form of equation of the line described. So first we got some parallel lines. The thing we need to know about parallel lines is that they have the same slope. So if I look at the line that this is going to be parallel to, and I just look at its slope, I already have the slope for my new line because it has to match. And now I'm just going to borrow this like an x and a y and solve for b. Just like we've been doing, y equals mx plus b becomes 0 equals negative 3/4 times negative 5 plus b. 0 equals, I multiply to the top of that fraction, the negatives cancel out. 15 over 4 plus b. I subtract 15 over 4 from both sides. B equals negative 15 over 4. Now that an m and a b value, I write my equation. Y equals negative 3/4 x minus 15 over 4. All right, so that covers parallel. Let's talk real quick about perpendicular lines. Perpendicular lines have to have an opposite reciprocal slope. So this one here has got a slope of 1. If I turn that into a fraction, it would be the fraction 1 over 1. And the opposite reciprocal slope here, I flip that upside down and make it negative, would be negative 1 over 1 or just negative 1. So 1 and negative 1 are opposite reciprocals. This is just a long way of proving that. But 1 and negative 1 are opposite reciprocals. A check for that is that they should multiply to be negative 1, and 1 times negative 1 definitely multiplies to be negative 1. So I've got my slope m. Now I've just got to borrow an x and a y. And so I get 2 equals negative 1 times 3 plus b. 2 equals negative 3 plus b. What number can I add to negative 3 to get to 2? Let's add 3 to both sides and find out. B equals 5. So final equation, y equals negative x plus 5. All right, I won't finish problem number 20, but I will tell you the opposite reciprocal of 10 over 7 is negative 7 over 10 for my m value. Now you can go and find the b value. Maybe pause the video and do that real quick. Sketch the graph of each line. All right, we learned how to do this with tables, but then we said goodbye to tables and started doing it without tables, and it's not too difficult to do without a table. The thing is, you start at the starting value. If I've got a y-intercept of 3, I want to start by putting a point on the y-axis at 3. Then I want to find more points by using the slope, 1 over 2. If I just write that off to the side, I can see that this kind of matches the form rise over run. I can clearly just find more points by going up 1 and over 2. So if I go up 1 over 2 from the point I already have, I get a new point. From this point, I can find another point. From that point, I can find another point. And I can go backwards by just reversing the whole thing. Instead of going up 1 over 2, I could go down 1, backwards 2. And you see it keeps it on a straight line. Let's go ahead and get on our straight line tool, which for you might be a ruler. Connect them up. And there is your line for number 21. All right, I think you can do 22 on your own. I will just say for negative 5, that means we go down 5 over 1. I think you're good on 23 and 24. All right, 25 through 28, we need to write the slope-intercept form of something given in standard form. This means just take this and get it into that y equals mx plus b form. We need to just have the variables in the right spots. M and b will be numbers, that's fine, as long as y and x are in the right spots. So with number 25, I'm going to take the 2x and move it to the other side. This negative stays behind though. Negative y equals negative 2x plus 2. How do I get rid of that negative? You got to divide it away. Notice also up in this step, I didn't really point that out, but I took the negative 2x and I put it in front of the 2. Totally allowed to do that, and it makes it look more like y equals mx plus b. Now I divide every term by negative 1, and I get my final answer of y equals 2x minus 2. Let's do just number 28 real quick. I'm going to take that 5x away from both sides. Circle that better. When I do this, I'm going to shimmy it in front of that negative 8. So I'm going to have 8y equals negative 5 x minus 8. Divide both sides by 8. We'll divide every term by 8. Y equals, and I want to write this as sort of like a coefficient, negative 5 over 8 with the x out in front, so it looks more like mx plus b minus 1. All right, and then we put it all together for these last problems here. Convert to y equals mx plus b, and then use that to graph. So I'll just do 29. I'm going to subtract the 6x from both sides. Let me just copy it first. Move that 6x to the other side. Negative y equals negative 6x minus 3. Divide every term by negative 1. Then I get y equals 6x plus 3. Now I can put a point at my y-intercept of 3. To get to my next point, I can go up 6. 1, 2, 3, 4, 5, 6. I'm somewhere over here over 1. Or I can reverse that, go down 6, 1. Connect those up with a straight line. And we're done. All right. Hopefully this has been helpful. Good luck to you the rest of your